hear the word about quantum, we know that it's small particle. Okay, quantum means is a subparticle of subatomic. How this subatomic is used for computing big process. Okay, so we know that in quantum computing there is a subparticle. Within this subparticle there are many within the subatomic there are many particles are there, electron, proton, neutron, like this, all are revolving around the within the atomic subatomic. That is the basic principle behind that can be used for computing purpose. Okay, now I will show one simulation how this quantum computing is faster than the classical computer. Okay, when you want to find the food, for rat is finding the food, we know that puzzles. Okay, this is a puzzle. If you have the food here, if you place the rat here, and it will search and it will come back and then search, it will come back and then search, finally it will reach the position. So this is the normal search, and how the quantum search will happen. You see this, you can understand some concept behind this, what it is.
Search every path randomly to reach the destination, and we cannot claim that the path we find is the shortest until we visit the entire search space. However, with quantum search, we start with one agent, but whenever the agent encounters multiple paths, we send one agent to each new path. This allows us to search more quickly. The twist in this situation is that all those agents you see on the screen are just one single agent in multiple places. This phenomenon is known as quantum superposition. At the end, when we find the solution, all the other agents disappear, and the real existence of the agent is at the destination. It's strange, but that's how quantum computers are going to work. When we compare agents, we can see that quantum computers can easily win. Even with an increase in problem size, the complexity of the problem for a quantum computer will be linear. Share your thoughts on this.
So when the quantum computing search is complete the process,
In a normal search,
but
our agent
search is still it is not completing. That is the phenomena of the quantum computing search, how fast it is working. So we will see the basic fundamental of this. So my presentation goes like this: quantum theory, quantum computer, superconductivity, the material which are used in quantum computing, and components of the quantum computers, and classical computer versus quantum computer, and quantum principles, quantum algorithms, applications of quantum computing, all this. So the quantum theory, what it says, the quantum theory set of the principles that govern the behavior of the matter and energy on subatomic level. So subatomic level is a minute part of the any material. Okay, that's called atom or the subatomic particle, which has proton, neutron, electrons, all these revolving. Okay, even a dead materials. If you take this, if you take the minute or subatomic of this, it's revolving, even if it is a dead. Alive materials also like this. Any material, the minute particle is still alive. Okay, that is the basic principles of this. And second point is the quantum theory deals with the behavior of particles that are incredibly small and often behave in ways that some counter initiatives. And then the core principles of quantum theory include the superposition. This is a principle behind this, entanglement and the uncertainty principles. So superposition, we all know that. What is superposition? If you take this fan, okay, how many blades are there? 3. If it is off, we can say 3. If it is a running fan, we can't say how many blades are there. Okay, this is called superposition. Where the blade is there, we don't know. Okay, this is called superposition. And entanglement. What is entanglement? A particle, if it is divide or it is distinguished, or you can keep it in anywhere, the distance is not a matter. If it is 1, here also 1. If it is 0, here also this 0. That is called entanglement. So this is main, even if it is one particle in earth and another particle in moon, if you change, there also this is for communication purpose, we can use the entanglement. That is the entanglement. And uncertainty principles, we cannot predict when it will be static and when it will be dynamic, where it is there and where it is not there, because it always revolving. When it is, when if you touch this, what will happen? We know that three blades are there. Until if you are not touched, we know how many blades are. That is the principles of superposition. That is the advantage of this. So suppose in a classical computer, I have 4 bits. Okay, 4 bits. So how many variations I can get it? 2 power 4. That means 16 variation. First value is 0000. The last value is 1111. So at any point of time, I can get one of these values. This is the classical computers. Whereas in quantum computer, all these 16 is available at a time. That is the advantage of the superposition. In the research they are developing, okay, still we are not utilized. Okay, quantum computers they develop, quantum memory is not developed, quantum measurement is not developed. Using this principle, somebody is developing algorithms and they are working with the digital computers and simulating. Okay, so it will take another time, another nearly 20 years to have quantum computer in our hand. Okay, it is now in research. Why quantum computers is good? CPU is designed in nanometers. Okay, now they are telling 2 nanometers. CPU can be designed in 2 nanometers. What is the drawback when you go for small device? When you reduce the size, what will happen? You know Moore's law. Gordon Moore told that every 18 months, your performance will be double, your size will be reduced. Okay, but when you reduce size, is there any drawback? Complexity will increase. Heat, due to the heat, the functionality may be may not be correct. Okay, it may be this what is it called? Malfunctions. Okay, when you say right, it may not be right. That will happen. Okay, that is the one advantage. We can't go further, reduce the size, but still the classical computers are working in fine, and many applications we are using the classical computers. That is, we cannot say that the quantum computer will replace the classical computers. That we cannot, that statement cannot be accepted. But when you reduce the size, that is the problem. And another point is the CPU clock speed is limited to avoid hotspots. So clock rate, now we are saying 5.3 gigahertz. Okay, so when you increase the frequency, what will happen? When you run fast, what will happen? Your heartbeat will rise. After sometimes your body will get heat. Similar way, when CPU is functioning in high speed, okay, definitely the heat will be generated. The heat is a it is a induced to do malfunctioning. Okay, that we should not. That is another disadvantage of the system. Another one, semiconductor transistor stops working and short circuits if the temperature gets too high. This is the malfunctioning principles. And when this happens inside the CPU, the current through the transistor rapidly rises. So it will become conductivity. Okay, normally it should be a semiconductor. It will become conductivity. We cannot use it. Okay, that is the problem in the CPU. This what the quantum researchers are telling, that because of this we are moving to the quantum computer. Can we say that whether the research on classical computer will stop here? Definitely not. Okay, definitely the people will think in a different method to use the classical computers in a better way. And the classical computing and quantum computing. So here the computing units, we know that it's a transistor 0 or 1. At a time when you read, it may be a high value or it may be low value. That is the two principles we know that. Okay, two logic gates. Whereas in quantum computing, either 0 or 1 or simultaneous value. That's what I told. Simultaneously we will get 1 qubit. If you have 2 values, we can get simultaneously. If you 2 qubits will have 4 values, I can get simultaneously. If n number of qubits, that much of value I can get. That is the one of the quantum computing. And second one is quantum capacity. So capability to increase linearly. That is when you increase 1 bit, okay, 2 power n. So 2 power n things will, at a time one of this will be, we can get it. Whereas here all the values will get. Okay, super. 2 power 4 increased by 2 power 5. What will happen? 16 bit will become, 16 location will become 2 power 5, 32 location will come. But out of 32, one of the value we can take at any time in classical computer. What they are telling, in the quantum computing, all the 32 value we can uptake. That is the advantage of the quantum computing. And error rates, low error rates, because it is we known values. Here 1 means 1, 0 means 0. Whereas here it may be 0 or 1, we don't know. Okay, so there may be a error rate is higher. People are working how to minimize the error. And the last one, stability, suitable for runtime processing, because runtime we know the values and we can process it and we can give the result. Suitable for the complex problem like searching, okay, like searching and AI, machine learning, all this. We cannot use quantum computing for A plus B. If you use that, you are not in the right person to use the quantum computing. Quantum computing you should use for searching the name in the Aadhaar card, because it's a huge database, and search the name, searching the photo in the Aadhaar card. So in such case we can use the complex problem. This is quantum computing is very suitable. So this is a machine. By seeing this machine in 1950s or 40s, okay, Charles Babbage developed a mechanical machine computing. It's like a room size. Okay, it's a mechanical machine. If you rotate A 4 times, if you rotate B 3 times, and lever we can change it is add lever, and final wheel will rotate 7 times. This is a mechanical process they develop. Okay, this is a Charles Babbage machine. So like that you can have bit size. So many wheels are there. This is a mechanical system. And then they use motorized, and then they use the electronics, and what we are using is a electronic computing. So similarly, when you see the quantum computing, it's look like this is a process. We can't understand where the CPU is there. Okay, this is mainly to that quantum particles to work in this environment. They develop this, and this is the room size, and they are using here where the CPU is there. We don't know, because still it is in the research. And why quantum computers cantilevers hanging from the ceiling? Yeah, why they are hanging from the top to bottom? Okay, so the reason why is they primarily focused on maintaining the stability and integrity of the quantum processor. Okay, if you put, the vibration will be more, because the quantum particles vibration is there. So if you hang, due to the vibration will be reduced, and to minimize the mechanical vibration and potentially disturbing delicate quantum states of the qubits. To find out the quantum states, whether it is 0 or 1 or any of the 0 or 1. And then vibration can come from various sources. Vibration may happen from the external force, maybe in the ceiling or in the earth. Which vibration will affect more? Because people are walking, this vibration will be more than ceiling vibration. When you have the fan, there will be a vibration. Am I right? Okay, when you have fridge or when you have AC, there may be a vibration. Nowadays they are reducing the vibration from the AC unit, and fan, noiseless fan also is there. Okay, and the suspension method helps isolate the quantum processor from ground vibrations. So to avoid the ground vibrations, the suspension method is used. And then cryogenic components of the quantum computer are suspended in a manner that minimize the heat transfer from the surrounding environment. So when you from ceiling to down, the heat will also be reduced, because this supercomputer has to work only in the very cold places, not in a room temperature. 0 Kelvin. What is a 0 Kelvin? Minus 273. Okay, that is the temperature we need to maintain. So it is very difficult to use in a normal temperature. In those days, in the earlier days, people said that when you use a computer, it should be in AC. But nowadays, we are using on the lab, and also we can take anywhere, because the zinc transfer. Okay, zinc's cooling machine mechanism is used, so we can use anywhere. Like that, definitely the researchers are working in how to use this one in the room temperature. When it comes come to work in a room temperature, then only the application will be, then only the development will be more. That's what. It provides easier access for maintenance and adjustments. When it is in AC, the cooling, that is a cooling, when it is cooled, definitely it's a dust free, because when subparticle is working, it should be a dust free environment. That's what we are having in our research center. What is it called? 1000 particles, 100 particles, 1000 particles. Okay, that type of environment we need to have this. And then the image of the quantum computer we have seen is quite striking and unlike any classical computers we have seen, because if you see 60 years or 70 years back, the classical computer also looks like this. It's a room size. So similar way we are seeing that. Definitely after 20 years you may have quantum computer in your hand. Definitely. The unique appearance is required to operate the quantum computers on superconducting qubits. So, quantum computer work with the superconductivity materials, not semiconductor, not conductive materials. So, when conductivity will become superconductivity, if it is temperature is low. That's what they are telling. 0 Kelvin. So, cryogenics, the science of producing and maintaining extremely low temperature, is a crucial for operation of the quantum computer. That's why it is not available in many places. It's only in research. People who can invest more, they are developing this quantum computing. And quantum systems often operate in the millikelvin, that is called minus 270 degree to 0 Kelvin. And superconducting qubits need to be maintained to 20 to 100 millikelvin. So we have to maintain that much of Kelvin temperature, very cool temperatures. Thermal energy causes decoherence, because when it gets heat, the decoherence means in order. Decoherence means it's not in the order, where the qubits lose their quantum state. Okay, at higher temperature, qubits interact more with the environment, leading to error in the combination. We should not use higher temperatures. By cooling the system, these interactions are minimized, allowing the qubits to maintain coherence and perform the complex task. Okay, calculations. At this extreme cryogenic temperature, materials become superconductors. That's what we know, that basic principles of the superconductivities with zero electrical resistance. That's what low resistance, that is called no particles, the resistance will be less. So cryogenic provides a stable and ideal environment for quantum computers. Google and Intel rely on advanced cryogenic systems to enable their superconductivity quantum computers. There are many players, companies are playing the involving in the research. So this is a superconductivity materials. Superconductivity is a phenomena in certain materials is extremely low temperatures, characterized with exactly zero electrical resistance. And this phenomena is nothing but losing their resistivity absolutely when the cooled sufficient low temperatures only it will be used. The most of the common superconducting materials, we know that. What are all the materials we can use? Okay, nibonium and even aluminum also they can use, and then nibonium nitrate, and then occasionally yttrium, barium, copper oxide also they are using. People are working. What are all the materials can be used for the. Note, these materials are not subatomic but are used to create superconductivity material. Quantum circuits, where the qubit's quantum state is encoded in the collective behavior of the electronics. Okay, that is the principles behind this. And this is the picture of the subatomic particles. We have neutron, electron, proton and nucleus. All these are there. So it is revolving. So we don't know which position, when and position, what is the position, that is very difficult. Okay, some people working on electron, some people working on photon. When you use photon, they use a light source to detect. When you use electron, there is a another phenomena to detect the values. And different types of quantum computers. Okay, one is superconductivity quantum computers, another one is trapped ion quantum computers, and photonic. That's what I told. Use the photonic materials for quantum computer, and topological quantum computers. Cooling it's required cooling methodology, and quantum dots. Okay, these are all the basic principles. They are using different materials. Still, people are working. Even in our college, we can find out what materials is superconductivity. Okay, superconductivity materials and how to take the subatomic materials. Components of the quantum computers. Quantum hardware is one, and another one is quantum qubits, quantum gates, and quantum circuits, and quantum measurements. These are all the 4 principles required to develop the quantum computers. So, in the logical, normally we can, normal conventional method we can call it as bit and byte. Here we call it as qubits, that is called quantum bits. And quantum gates, the normal logical gates are there. What are the logical gates? And, or, not, XOR, okay, all this. Whereas here quantum gates are different, okay, the Pauli gates and NOT gate, control gates are there. So that based on the principles behind, physics principle they are using. And quantum circuits is number of qubits is, and operate on the qubits will get the values. And quantum measurement is a final. If you, that's what I told, if it is spinning, no problem. If you want to measure, what you have to do? You have to touch. Okay, then if you touch, it will be collapsed. Okay, you will get one value, either 0 or 1. That is the principles of the quantum measurement. If they use photon, they can use light to detect what is the position. Okay, if you use electron, there is another method to detect the what it is. Hardware is nothing but serves the physical platform of the quantum computing, which includes superconductivity circuits and trapped ions, photonic devices. This is small subatomic level. They are forming the, to create that, the cryogenic method of machines they use. And then maintaining the qubits in stable quantum state requires the hardware to under the precise environment control. So you want to maintain the state, whether it is 0 or 1 or 0 1, you require a room temperature, not below room temperature, that is a Kelvin values we need to maintain, then only it is possible, such as ultra cold temperature and isolation from external noise. Okay, even I saw one photo, the Google Sundar Pichai is near the machine. Okay, it is difficult to take the photo. Okay, they will not allow you to enter into that. You should wear some material and then. Okay, so they, because he is the owner of the company, he can, not owner, CEO of the company, he can do anything. What he can invest another 1,000 crores, whatever they will. And quantum hardware also contains the infrastructure of controlling and reading out the qubits. That is, how to control the qubits, quantum bits, how to read the qubits. That hardware also is required. Until if this hardware is not there, then there is no use of quantum qubits. If I am there, if I have money, okay, if I spend the money, then only the value is there. Okay, if the quantum bits are there, we must know what is its value. Then only we can use it. Otherwise, quantum bits are there. What is the use? Then we need to take. And this is the small picture about that. The bit means it may be 0, 100% 0. It may be 100% 1. Normal bit, either it may be 0 or 1. It's low or high. Whereas in qubit, 0 is there, 1 is there, and 50% it may be 1 or 0. So all the options are there in the qubit. That's what they are telling. This is called superposition. This is called superposition. Okay, we don't know whether it is 1 or 0. And then entanglement, when the qubits are placed in a different location, okay, both are identical. Okay, what we can say, twins சொல்லுவாங்க தெரியுமா, ஒரு இடத்துல அடிச்சோன்னா இன்னொருத்தருக்கு வலிக்கும்னு சொல்லுவாங்க தெரியுங்களா, ட்வின்ஸ் நிறைய படத்தில் பார்த்துருப்போம். ஆனால் ரியல் அப்படி இருக்கான்னு தெரியல. ரியல் ட்வின்ஸ் இருக்கா, ஒருத்தருக்கு இல்லைன்னா இன்னொருத்தருக்கு வலிக்குமா? கேட்கும், பட் really it's happening or not? True. Okay, so that's what entanglement, even if it is split, that's what I told. One qubit in earth, one qubit in moon, when you change this also will change. So mainly this entanglement is for quantum communication. There are people are working on quantum communication. Okay, that is the advantage of this. And then qubits are the fundamental units of the information in quantum computing. It's the fundamental units. One qubit will store, it will give 3 values. What are the 3 values? 0, 1, 0, 1. We have to say 0, 1. So what is the meaning of that? We don't know. It may be any position. Okay, that is the thing. And classical bits which can only either 0 or 1. That's what the quantum superposition says. When you have 2 bits, all the 4 values we can take at a time. When you have 3 bits, all the 8 values you can take at a time. So if you have 32 bit, that much. If you have 1000 qubits, that much of value I can take. That is the advantage of the quantum bit. So qubits is a superposition to exist in multiple states in the same time. Underline this statement. Exist multiple state at the same time. Is the underlying statement. Quantum basic principles. Not 0 or 1. It both state will be exist. That's what it's giving the first the diagram agent, multiple agents will be there, and then it will search, and then finally one agent will be written. Okay, that multiple agents because of the qubits. And then qubits can be physically entities such as ions, photons, and superconducting materials. The ability to entangle with other qubits supports the correlation, because correlation with one and other both are, whether it's upper direction, this also will upper direction. When it is a lower direction, this also lower direction. Okay. So this will use to computational capabilities of the quantum system. Quantum gates are the building blocks of the quantum circuits. Okay, using these quantum gates, we can build the blocks. Suppose you want to design an AND gate, what you will do? You AND gate design you must know what is the input and what is the output, and then draw the truth table. Based on the truth table, you can find out the expression. Once you know the expression, and use the transistor to soldering, and you'll get the ready. 2 input and 1 output, your circuit is ready. Like that, in the quantum building also, if the 2 inputs are there, and what will be the output, you have to create the quantum circuit. And manipulate the states qubits, applying the certain quantum operations like flipping states, creating superposition, or generating entanglement. These are all possible with the help of quantum gates. And operate on complex amplitudes, making it possible in transformation quantum states. There is a 2 Adama gate. One person will develop the gate for the superposition 0 or 1, and C naught control NOT gate is for entanglement. Okay. And quantum circuits, a sequence of quantum gates are applied to a qubits. Quantum circuits from the structure of the quantum computation. For compute purpose, we have to design the quantum gates. And these circuits encoded algorithms that carry out the task like factorization. What do you mean by factorization? Finding the factorization for the prime numbers. Okay, for a big prime number, if you want to find out, you have to try from 2 to n minus 1 or half of the values. If it is a bigger number, it is very difficult. It will take longer time in the conventional method, but it will support very quickly. Factorization method is and optimization and data analysis. That's why quantum computers are very much useful in machine learning and AI. Not for ordinary computing purpose, we should not use the quantum computing. And quantum circuit begins with the initializing qubits. Okay, each qubits we need to initialize, followed by applying gates, and end with the measurement. Okay, when you measure only, you will get the values. What is the value? The design and complexity of the quantum circuit determine the efficiency of the computations. So for any, even so, there are 2 algorithms, Grover algorithm and Shor algorithm. They develop like this. Quantum gates only use the Grover for searching, and Shor algorithm for what is it called, security, cryptography purpose. Okay, and quantum measurements to a process of extracting information from qubits. This is very, very important. I told, when you want to measure, it will system will be collapsed. Either you will get 0 or 1. You won't get the both values. Okay, by collapsing their quantum states into the classical outcomes. So, we will get the classical outcomes 0 or 1. We won't get the 0, 1 and the position together. And this is the key step of the quantum computing, as it translates the probabilistic quantum. So probabilistic method means the quantum, what it will do, suppose you want to search a number, okay, it will search many times, and probability method will give the result. This is, suppose which one is, we will found the maximum times, that is the result. That is called probability. It may search 100 times. So which one you 100 times, which one you got more times, that is the final result. Since the quantum will do parallelly, this for doing all the operations, it's very limited fraction of second it will complete. And the measurements can affect the state of qubit. Okay, so the performing the strategically preserves the integrity of the computations. Advanced measurement techniques. Here still we need to have the people are working measurement how it is possible, whether it is possible to measure the superposition, because when I told when you measure you will get only classical output. If you want to get the 0 or 1, we need to develop a system. Okay, that still people are working on it. Okay, this is the comparison between the classical computer and quantum computing. Okay, what it says, basic units bit, there is qubit, and here state either 0 or 1. There you have 3 states, 0, 1 and superposition 0, 1. And logical operations here is and or not, whereas here quantum gates, Hadamard gate and C0 gate. And then speed limited by the classical physics, because when the frequency is increased, the speed will increase, whereas here can perform certain calculation much faster than the classical computers. And then memory stored in binary gates, stored in qubits. Again here the people working on how to store the values in the qubits. Okay, there is a research. And entanglement not possible, but here is possible. Error sensitivity, which is not a sensitivity but extremely sensitive to noise and errors. Quantum computer we cannot say that it is 100% error free. There is a noise, error will be generated. And then application software, gaming and simultaneous. We can use any application in digital, whereas here cryptography, chemistry, analysis, machine learning. What they are telling, if you develop a qubit of 200 bit or 400 bit, the password in the world can be cracked within a fraction of a second. That's what they are telling. Okay, this already has shown. Okay, normal search it will take time, whereas quantum search will complete, because multiple agent will work and complete find the path. Normally, நீங்க சின்ன வயசுல இந்த puzzle போட்டிருக்கீங்களா? What is the method you use? How many of you tried from this side? How many of you tried from this side? இந்த சைடு தான் ட்ரை பண்ணீங்க. நான் இந்த டைம் ட்ரை பண்ணி got it. இது வந்து it is easy to find the way. Here you will have multiple results. Here you will get, but both are same. Okay, this is a reverse process and this is the followed. And disadvantage of limited parallel processing, but we can't say that one because still the people are working in multiprocessor, parallel pipelining, all this, but there is a limitation because of the superposition. And then inefficient for certain types of problems. Sometimes if it is inefficient means it will take long time. That is the inefficient. Okay, it will take long time, and quantum computing will take only fraction of seconds. And limited by classical physics. Okay, when size is reduced, the problem will come in the classical method. Advantage of the quantum computing, massive parallel processing. Okay, we can go multiple. So due to this superposition, we will go for massive parallel processing, and efficient for certain types of problems. This is not efficient for ordinary problem. நாங்கள் போய் மேட்ரிக்ஸ் மல்டிப்ளிகேஷன் குவாண்டம் கம்ப்யூட்டரில் போடுறோன்னு ட்ரை பண்ணாதீங்க. Okay, A plus B ட்ரை பண்ணாதீங்க. That is not correct method. Okay, you can try for the searching a name in the Aadhaar card, Aadhaar database search பண்ணுறது. That is a very good process. And non-deterministic quantum computing. Okay, here finite value is very difficult because the probability value it will give, it won't give the finite value. That's why it's required multiple multiple solutions, and the probability maximum value that will declare as the answer. It will declare that one as the answer. Disadvantage of the quantum computing, it's required specialized hardware. What I have seen that from ceiling to down, and room temperature it's below Kelvin, that is 0 Kelvin temperature we need to maintain, and expensive. Okay, we cannot ordinary company we cannot do it. In those days 80s computers only they used only the Navaratna companies in India. What is a Navaratna company? BHEL, okay, Bell, Navy Lignite. For those companies only they bought the IBM computer they used. Okay, they use mainframe. Okay, later they reduced the mainframe into mini computers. There, small companies use the computers and then reduced into personal computer, microcomputer. Thereby, every shop they use. This is the hardware side, and software side. Two giants they develop two softwares. That is why the computers are more popular. What are the two softwares? Microsoft, Google search. Another one is Microsoft. The best one is MS Office. Without MS Office, I cannot imagine how to use my computer. Okay, if there is no MS Office, I can't use the computer because that is the one take all the computers to the individuals. Okay, so it is expensive now, but definitely after 20 years, everyone will have the quantum computers in your hand. அது எப்படி இருக்கும்? We don't know. Okay, what is the size and how it will be fabricated? We don't know. And limited applicability, now it is a limited applicability because it's a higher versions only we can use. Later we can use for the small version also. And fragile, the quantum computer is a fragile and sensitive to external disturbance. Fragile means what? Easy to distract, okay, expose. So which cannot cause which can cause the errors. That is a disadvantage of the quantum computing. Quantum principles, he is a man block, flexi block, to find out the quantum in the sphere. Okay, this is a z axis, y axis, x axis. Normally number 3D வரணும் எப்படி வேணும்? Y, x and then z. இங்க எப்படி இருக்கு பாருங்க. Okay, this is z and y and z. Okay, x axis. So your atom may be ஒரு ball think பண்ணிக்கோங்க. பாலோட சர்ஃபேஸ்ல எங்க வேணாலும் atom இருக்கலாம். Okay, டாப்ல இருக்கலாம், பாட்டம் இருக்கலாம். So this measuring this you use expression. Okay, block sphere. This is called block sphere method and geometrical representation of the few state space of the two level quantum mechanical principles. For this he got the Nobel Prize. Okay, and here there is one tool is there, simulation. How when you apply the gate, what will happen? I think Senthil Kumar will explain about that. And the superposition, we know that suppose if you have 3 bit, all the possibilities we can take at a time. That is the advantage of the superposition. So this is a tossing of the coin. Till now we don't know what is, whether it is head or tail. Only if it is landed, only we know that whether it is head or tail. So this is called superposition and this is called measurement. When you measure, it will be collapsed. Your superposition will be collapsed. And then entanglement, this is an example. When the cat is in 2 box, the twins are if it is alive, this also will alive. If it is die, this also will die. Okay, this is a probability, and this is a 2 particles. The distance is not a matter. Okay, x distance, the positions will be same. That's called entanglement. Quantum interference. Suppose if I have passed the light, and then I have to split, again I will get the same. Here the deeper lights will be there and here also lighter. So this position is called Young double slit experiment method to find out the light rays. வாட்டரில் அலைகள் பார்த்து 2 கல் போட்டுன்னு வச்சுக்கோங்க. ஓகே, அலை போயிட்டு இருக்கும், பட் one place it will merge. So quantum interference is a phenomena where the wave functions quantum particles. This will either quantum particles, it may be wave or it may be atoms. Okay, ஒரு wave particle இருக்கலாம், movement ஆகவும் இருக்கலாம். The wave particles are called photons or electrons, can be interacted with each other and cancelling out their effects. They will cancel. This is called quantum interference. And this happens when the particles are in superposition, existing in multiple states simultaneously. So these are all the gates they develop in quantum computing. One is X gate, Z, H, okay, Adamant gate and Pauli gates are there. Okay, these are all the principles of this. When you apply, what will happen, we can find out. So this is the gates H gate, XYZ, Pauli XYZ and phase shift S and T. And then the sphere la pathina phase shift also is there. Either 0 or 1 or phase shifts also will be there, whether minus or plus I, that is a complex value also will be there. Okay, these are all the 1 qubit. When you operate, what will happen? Okay, when 0, when you use NOT gate, you will get 1. When you get X naught, it will become 0. Y, it will get I Pauli. This is either it is a minus negative value or negative value or positive value. So similarly, Z, Pauli head, adamant gate, and S, all this when you apply for 1 bit, what is the value? So when this adamant gate will give the superpositions 50% 0 or 50%. Similar things when you apply for two bits, what will be the result? So this is very important. Then only we can use the quantum gates for our applications. So that is called control gate. C naught is called the control gate that will give the values. And this is a tool. Okay, this is called IBM Composer. So this is quantum bit 1, quantum bit 2, 3, 4, and then this is the output value, control circuit values. Okay, so when you apply this adamant gate on this, you will get the values. So this is so when you have bit all these values, we can get the sphere position will get, and the equivalent Python program we can get it. Okay, use this Python program, copy and run in Colab, the similar output we can get it. So this is for designing the CAD. You can, it is a free login, Quantum Composer. Get login with Google mail ID and you can start working on this. When you click this, it will tell what is the use, adamant gate, and what is the principles, and what is this. Like that, each one will have the meaning, like and, or, not, like that will have. When you apply this, you will get the values. This is called output. Okay, this is direction and 1. This is a 0, 0, 0, and direction also good because it's a vector quality, not only a scalar, it's both vector also is there because direction is also very important. And this will get the Qiskit is a tool developed by IBM. Okay, you can use that for developing the quantum programming. So this can run in the quantum simulator. It's not actually run on quantum machine. It will run in only quantum simulator. And existing quantum algorithms, these are all the algorithms they developed. Even now we can work on develop an algorithm to search anything. Okay, Aadhaar name or anything can search. So already they develop. These are all the algorithms they use, experimental or classical, exponential over classical, because it will work on experimental method. Grover algorithms mainly is for searching. Okay, the speed is phenomena. And then this is SOAR algorithm mainly for cryptography. It breaks the RSA algorithm. You know RSA algorithm for public key, public and private key method. Okay, it breaks that one. It will find out the probabilistic method of all the keys and then you can break the RSA algorithm. Like that, many discrete logarithm algorithms. Many of the people got the awards also when you develop this algorithm. These are all the applications of the quantum computing. Okay, you can use any. That's what you should not use quantum computing for lower calculation, computation you should not use. Think about bigger problem and how to use. For that you have to develop the circuit, not writing the program, circuit, and then find out the program in the Python and then you can run it. If you are well versed all these circuit, we can straight away write the program in the Python and then you can use it. And the companies involved in quantum computing, okay, tech giants IBM, Google, Microsoft, AWS, Amazon Web Service, and Intel. Okay, hardware D-Wave, IonQ, Quantum, Quantanium, Extensive, emerging startups. Many startups are working on it, and software innovators, QCware and Riverland, all this, and supporting ecosystem. NVIDIA also working on this. You know what is NVIDIA? They are pioneering developing GPU, okay, graphical user process, GPU, graphical processor unit. And India also they are working on it. It's called National Quantum Mission. They invested 6,000 crore for this. Okay, we can apply and we can start working on quantum computing. Okay, the key initiatives, and there are 4 areas and 4 premier institutions are working on it. For quantum computing, IISc Bangalore, they are offering MTech quantum computing. And then quantum communication, IIT Madras, they are assigned for this job. And quantum sensing and amplifier is metrology, but IIM Bombay. And quantum materials, IIT Delhi. And these are all the tools you can work. Okay, QSCIC is IBM, CRIC is a Google, and Microsoft, they develop QDA, quantum development. Okay, and for us physical, these are all the method is there. You can start QSCIC is very easy, understand, and CRIC also in the Google Colab we can use this. And these are all the tools. What is SDK? Software Development Kit. Okay, that's called SDK. Where you can type and run. Okay, that is a SDK development. And challenges in quantum computing, effective quantum computing has to face some challenges and limitations. One is quantum decoherence. It's not a coherence. இப்படி தான் work ஆகும்னு சொல்ல முடியாது. You can give any values. Since it's depend on probability, we cannot predict this is the value. And error corrections and scalability and fragility and qubit interconnections and extended noise. Okay, these are all the problem now. If you work any of this, how to reduce, how to minimize, definitely will get chance. And difficult to collaborate and high cost initially. Normally computers also initially it is high cost, now it is very cheaper. And I got the references from this quantum computing, quantum composer, Blacksphere, and this is the software, and even I got information from ChatGPT. Okay, thank you for your patient listening. Any questions? I'm very happy. PhD thesis மாதிரிலாம் கேள்வி கேட்கக்கூடாது. சொல்லுங்க, எந்த ஸ்லைட்? இதுவா? கேட்டா? No, it is simulated. Simulated. You cannot apply with this. No. Simulated. Yeah, it is all what we have seen, that this is called simulation only. Yes, correct. Correct. So some 10 minutes time they are giving, you can submit your program to the quantum. The 10 minutes is enough to solve bigger problem. But we need to ready to write the bigger problem before asking 10 minutes. 10 minutes is a free of time. IBM is giving the quantum computing free of time. For monthly, once in a month they are giving. So you have to ready to work. You know, it will take fraction of a second, it will complete your process. So you have to use simulator and then ready to submit to their computer, ready to compute, submit your problem to the quantum computer. Yeah, this is free one. Free. See, that's what I told. IBM, in India, I think Bangalore they are having. Bangalore and CDOT also they are having. CDOT is having. You know CDOT? Center for Department of Telecommunication. They have the communication purpose they are developing. Taramani ingilla Pune il irukku. CDOT Pune. Ingilla. இருக்கு ஆஃபீஸ், பட் they have a quantum computer in ceremony. Thank you. Even I have some questions. Superpositions, we are telling that how to measure all these 4-bit means all the 4 values, all the 2 power 4 values will be available. If it is 2 power, because if I have 1000 words, I want to search Murali. Okay, in out of 1000 words, I need to search. So I need values. How to get values from the qubit? Okay, it's have still it's $1,000 questions. We need to work. People are working on it. Even in our colleges also, the students are working in this environment. We can find out. That's what I told you. You should not write program for A plus B. Don't try to write the program for A2. There is a full adder and off adder circuits are there. We are underutilization. Okay, so it's a lot of scope is there to work. Thank you.
Maybe superposition, but sir asked, I might be right. One set of processor is checking first who are starting with M. Second is checking who are all with U, narrowing down. Third is checking with who are all are having R as a third letter in their name. Summating all that and finding result in the arch instance.
So agent will search
Parallel
first
process. So இதை collaborate பண்ணீங்கன்னா கம்மியாயிடும். narrowing down.
one letter will send second. Yeah, that's
narrowing
a,
down ஆயிடும்.
like agents.
Superposition அப்படிதான் ஒரு பவரோடைய ஒரு சோர்ஸோட இன்புட் என்ன இம்ப்ளிகேஷன், இன்னொரு சோர்ஸோட இம்ப்ளிகேஷன் என்ன, என் நம்பர் ஆஃப் சோர்ஸோட இம்ப்ளிகேஷன் தனித்தனியாக கண்டுபிடிச்சி எல்லாத்தையும் இன்வெஸ்ட் பண்ணுறது தான் சூப்பர்பொசிஷன். Amy, I thank VMB for sharing from out and in and out of quantum computing.
Thank you. Thank you, sir.
ஒரு சின்ன ஒரு ஃபில்லர் பிஃபோர் ஒரு ஃபில்லர் கொடுத்துருக்கு. இப்படி இருந்தால் சரி ஒரு ஃபில்லர், அதாவது என்டாங்கிள்மெண்ட் ஒரு சிச்சுவேஷன். ஐ கன்சிடர் தட் ஜீவாத்மா பரமாத்மா, ஜீவாத்மா பரமாத்மா. Advaita states that